This video is teaching you how to approximate irrational numbers, more specifically, how to approximate square roots that are irrational with and without using a calculator. In order to be successful without a calculator, you truly need to know your perfect squares. That will be of extreme benefit for you to be able to do this type of problem. So let's begin by reviewing the perfect squares, and we're going to do that by using our number line that we did in a previous video. So please stop the video and copy down the number line as well as the square roots there. Again, these should be memorized very, very soon so that you are able to find the square roots of irrational numbers by knowing the perfect squares. Okay, so our objective is to approximate the value of an irrational square root without using a calculator first. So let's talk about the square root of 20. So if I know my perfect squares, I know that 25 is a perfect square and its square root is 5. So I'm looking at my number line right here. The square root of 25 is 5. Well, the square root of 20 has to be less than the square root of 25, but it has to be more than the square root of 16. So that means that the square root of 20 has to be between 4 and 5. So again, the square root of 20 is between 4 and 5, because 20 is between 16 and 25, which means the square root of 20 must be between the square root of 16 and the square root of 25. So the square root of 16 is 4, and the square root of 25 is 5, and that's how I got my answer. Now, the next question is, which one is it closer to? Is the square root of 20 closer to 4, or is it closer to 5? In order to answer this question, we have to think how close 20 is to 16, and how close 20 is to 25. So 20 is 4 away from 16, and it's 5 away from 25. So therefore, the square root of 20 has to be closer to the square root of 16. So that means the square root of 20 is closer to 4, because 20 is closer to 16 than it is to 25. Alright, let's move on. In this example, we want to use a calculator to approximate the square root of 72 to the nearest hundredth. Keep in mind that you are not permitted to use your iPhones or any kind of phone as your calculator in math class. You need to have a scientific calculator that does not include any of your personal devices. So, on a calculator, you want to look for the square root symbol. And on this particular type, the TI-30X2S, you are going to look right here where that x squared button is. And you should see above it, it's hard to see on this video, but right above that x squared is a square root symbol. Whenever you have a button that has something above it, to get the part that's above it, you have to use the second button. Or sometimes it's called the shift button. So to do the square root of 72, you would first type the second button, or the shift button, and then you would type the square button, which above it is the square root. So when you hit second, then the square button, and then you type in 72, and you hit equals, you will get 8.485281, and it keeps going on forever across your screen. So as we know, the square root of 72 is an irrational number. The digits don't repeat in any pattern, and it does not end. So we are asked to round to the nearest hundredth, so you have to know your place values. The first number after the decimal point is the tenths. The second number is the hundredths. And then the third number is the thousandths. So that third number in this case is going to help us know if the hundredths should round up to a 9 or if it should stay the same as an 8. When this number is 5 or greater, it makes the number to the left of it bump up to the next digit. So my answer, rounded to the nearest hundredth, is approximately, and that's what those squiggles mean, approximately 8.49. So the square root of 72 is approximately 8.49. We are now going to do a few examples of applying what I have taught you on these two pages of this video. So the next example is going to be finding the diagonal of a square. So please copy down this information. The diagonal of a square with side lengths s has the formula d equals the square root of 2s squared. Find the diagonal of a square with side lengths 18 centimeters. So once you have that written down, go ahead and resume the video, and I'm going to go ahead and get started with the solving. So d equals the square root of 2s squared, and we know that the side length is 18 centimeters. So I'm going to plug in 18 in for the s. So we have d equals the square root of 2 times 18 squared. Now we have to follow the order of operations, and we need to do parentheses first, then exponents. Multiplication and division, remember those two go together, so you do whichever comes first, left to right. Addition and subtraction go together, you do whichever comes first, left to right. Now, even though you don't see any parentheses, there really are some underneath this square root. So we need to do 2 times 18 squared first. We have to do the exponent first, so we have to do 18 squared. And we write out all of our steps, so it's the square root of parentheses 2 times 18 squared is 324. Then I have to do 2 times 324. So that's the square root of 648. And then I don't need the parentheses anymore because I've done everything inside of them. So I need to type into my calculator the square root of 648. To get the most out of this, you really want to do this on your own so that you know how to type it into your calculator. If you did it correctly, the square root of 648 is approximately 25.455844, etc. So it goes on forever across my screen. And so we cannot find the exact value. Let's go ahead and round this. Let's round it to the nearest tenth. So here is my tenth value. I look to the right of it. That number that I circled will tell me if I should change the 4 or not. Since it's 5 or greater, that makes the 4 bump up. So my final answer is approximately 25.5. And then whenever you are given a word problem with labels, you need to make sure you label the answer. So it's 25.5 centimeters. And that's an approximation since the square root of 648 was not rational. Moving on to the next example, you will see several of these types of examples throughout the year, so you want to make sure that you truly understand it from the beginning. In this example, we are asked to find we are told that the area of a square carpet is 150 square feet, and we want to find the length of one of the sides. So let's draw a picture. So I have drawn a square, and the inside of the square covers 150 square feet. And we want to know the length of the side. So I don't know it, so I'm going to put a variable x. And over here, we know that both sides of a square are the same length. So if I have x along the bottom, I can have x along the side. We want to know what x is being multiplied by itself to get 150, because the area of a square is length times width. So it's x times x. Well, another way to say x times x is x times itself, or x squared. So we know we have x squared must be 150. So in order to figure that out, we have to take the square root. Many students want to divide by 2, but be aware that that is not how we solve this problem. Do not divide by 2. When you have x squared equals 150, you have to take the square root to get x, not divide by 2. So x is going to be the square root of 150. So let's go ahead and plug that into our calculators. Again, to get the most of this video, you want to do that by yourself and then check your answer with what I get. So when I type in the square root of 150 into my calculator, I get 12.2474487, etc. It goes all the way across my computer screen, or my calculator screen. So let's go ahead and round this to the nearest tenth. If I round it to the nearest tenth, which is where the 2 is, I'm going to look right next door. Since that number is less than 5, the 2 stays the same. So we get approximately 12.2, and then the correct label is feet. So it's approximately 12.2 feet on each side. This will be the last example for this video. In this example, it says Mrs. Adesso's square bulletin board covers 12 square feet. How much border does she need to go around the entire bulletin board? So let's draw a picture of the bulletin board. We're going to start with a square. So do the best you can to draw your square. And the border goes all the way around the outside of the bulletin board. Alright, so we know that the area, because it covers 12 square feet, we know the area is 12 square feet. So this whole inside is 12 square feet. And that covers everything inside here. So we want to know what the length of each side is, because if we know that, then we can find out how much border we need. So this is just like the last example, but we have to do more with it. X times itself, remember that area is length times width for a square, so x times itself is x squared, and we know that's going to be 12. So remember, we do not want to divide by 2. That is a big mistake that students make. Do not divide by 2. What we want to do instead is take the square root of 12. So when you type that into your calculator correctly, your calculator screen should say 3.4641016, etc. So let's round this to the nearest tenth. We're going to look at the 4. The 6 tells us that we should bump the 4 up to a 5. So each side should be about 3.5 feet. So this is 3.5 here, and this is 3.5 here. Now that's all we had to do in the last example, but this one we have to keep going. I need to find out how much border I need to cover or to go around the entire bulletin board. So if I need 3.5 feet along the bottom, 3.5 feet on the side, 3.5 feet on the top, and 3.5 feet on the other side, I need 4 times 3.5 feet of border, which means I need 14 feet of border. And that's my answer.